In this video on C# Basics, let's talk about generics. So generics delay the type specification until the class or method is called. Data types are passed into a class or method as something called a type parameter. The class or method define the type parameter with the open and closed angle brackets with the capital T inside at the end of the name of the class or method. Type parameters are passed into the class or method within angle brackets at the end of the name of the class or method. Defining a type parameter as part of the class signature defines that parameter for the entire class. However, defining a type parameter as just part of a method defines that parameter for only that method. Looking at the syntax of a class type parameter, we can see that we have the use of the capital T inside of the angle brackets here after the name of my class within the my class signature. Then sprinkled throughout the class definition, we can see the reuse of this capital T to define specific instances of the type that each one of these properties and methods must either return or receive as a parameter. If we created an object of a type my class and passed into the definition a type integer as the type parameter, then that means the result property would also be of a type integer. The parameter for the my class constructor would be of a type integer, and the return value as well as the parameter value would also be integers for this returns object method. For the syntax of a method type parameter, we can see the use of the capital T inside the angle brackets here at the end of the returns object method. Now that data type is again reused both in the parameter and the return type for this method. Let's write out some code that uses generics. So up to this point, we've been doing something pretty taboo in the coding world. That is, we've been using, as part of our definition for properties and return values on our methods, of a type object, and that's just not very explicit. It leads to all sorts of potential confusion. So in order to create a type parameter on this iValue1 property interface, at the end of the name of the interface, I'm just going to do open and closed angle brackets with a capital T inside of it. Now I can use this type parameter of type T here to define the type that's going to be for this property called value1. I'm going to go ahead and do the same thing here for iValue2 property. As well as now the iSum method. And the iProduct method. Once we save our changes, if we go into the iValueIncrease interface, which implements these four interfaces that we just changed, we can see that we have the red squiggly lines indicating that there's a problem here. And that's again because we need to pass along some sort of type parameter. Now if I pass along the data type int, we could do that here for each one of these inheritance items. And this will satisfy the requirement by each one of these inherited interfaces, but there is a bit of a problem. The iValueIncrease interface is not going to be specifically used only for integer definitions. Perhaps we want to pass along doubles or decimals. So this is where generics can once again come to the rescue. I can specify here in the definition of my iValueIncrease interface to be of a type T once again. And now I can pass along that type T to each one of these other interfaces. Looking inside now our updated integer value increase class, we can see that the iValueIncrease implementation is not satisfied. We need to pass along some sort of data type to it as well. I'm going to go ahead and change this to a type of int. And now this int data type will be passed along to each one of these other interfaces. Now my updated integer value increase class is still not happy, but that's only because we still have defined that each one of these members is outputting a type of object instead of this now type specific int. So all we need to do is just go ahead and change this. So int, and int here for value 2, and the product and sum also need to return data type of int. We can see that this has satisfied the implementation of the iValue increase interface. Now if we go to our program class, once again we have a little problem here, but that's because the definition of our myMath object does not pass along a type definition to this interface that it's using. So we're going to go ahead and say this is of course a type of int, and now everything is satisfied. The myMath object is going to be requiring an iValue increase interface of a type int. And in our updated integer value increase class, we can see that yes, in fact, we do implement the iValue increase interface along with all of the subsequent requirements that are inside of that interface. Both the value 1 and value 2 are data type int, and the product and sum methods here are also of a data type int. Additionally, if you want to do a little cleanup here, we could go ahead and eliminate the int explicit conversions here, since we know value 1 and value 2 are going to be data types of int anyway.